Okay, continuing with the linear DP. Next problem is word break. So given a list of words as a dictionary and also a string which represents a word basically, and the question is here to say either true or false if the given string can be segmented into space separated sequence of one or more dictionary words. So here lead code, lead and code are two dictionary words, and if the whole lead code was also a dictionary word, then that would also be true. And if there is no such possibility, you have to return false, like in the third example. So here again I have to make sure that I go through each and every possibility. So at a given point, I can either check the whole string, and if the whole string is not present, I'll go and try to divide it at each point before I. So that's what I've done. And for 0th place, I can assign true. That means if someone is reaching that point, that means they are able to split it into proper dictionary words. And for each I am going to solve if that is true, if the whole string at I is a dictionary word, I'll just directly assign it as true. And if not, for in every other string with spaces, we'll try to find if the string is in dictionary and DP is true, then the whole DP will be true. So it's about the breakpoint. Like if one of these is not true, if one of these is not satisfied, then this won't be true and it will remain false. I'm going ahead with MaximumSubarray. It's basically MaximumSubarray sum, right? Yeah. So it's basically a cadence algorithm. And whenever you come across a sum which is less than 0, that which doesn't really contribute anything, so you make that sum as 0 and go ahead. But before making this as 0, you calculate, because if it exists, if only negative numbers exist, I should be able to take the maximum sum as well in negative. So you calculate the answer, max of answer and current sum, and then update the current sum. So this is cadence algorithm. Cadence algorithm is basically a DP problem itself, but it is reduced to the space is optimized, and it's basically the whole array size is reduced to order of 1. Max products array. So here again, it's more similar, and you have to find the maximum product. But the trick here is you'll encounter zeros, encounter negatives, positives. So here the idea is to keep track of minimum and maximum I mean, positive and negative product. And if at all you encounter a zero, what about that case? Like let's say here it's Subarray, and if you encounter zero, here actually they are asking Subarray that has Subarray. I mean here so number and maximum you're taking. So max of this and min of this. Basically, if it is zero, you're not going to consider it. Or because I have max some 10 and number 0. Max of our star number is 0. So max of r will be 0 again. And min also will be 0. But yeah, but so after 0, if you are encountering 1 or something, some other number, then in that case you are basically multiplying max with number which is 0 and also checking it with the number. It's kind of you're leaving the 0 part in the previous case, the previous loop, and then continuing with the current number. So this num is for that case. Otherwise, max for 5 would be just max of our star the number, and the result will be maximum of these. And you're going to swap the numbers when it is less than 0. The way it is being handled here is key to solve this problem. Jump game. Here you're given a number array and return true. And so basically each number represents the maximum number of steps that you can take from this position. That means you can either take 1, 2, 3, and so on till the number of steps you can take. So at 2, you can just take 1 step and go to this position, or take 2 and go to this position. So the key idea here is, if you keenly look at it, you can go to each and every point. That doesn't matter where, what, like how many steps you are taking from the first or the second or whatever. So it's like you either go to first or second. I don't need to really consider how many steps I'm going to take. I just need to consider how many steps I have. So like I'll take 1 step and go here. So that will reduce my steps. My current steps will be 1. And the available steps is 3 here. So either I can pick 1 or 3. I think 3 is better than 1. So I'll pick 3. I can go to any place, right? Based on the available steps. So if with 3, I come to next position, and that will make my current steps as 2. but the number of steps in that position is 1. So I'll pick 2 as my number and go ahead. So this is a key point here. Again, it's not sure if this is any DP you can kind of cadence, but it's more of greedy problem, but it's also considered as DP problem. Think it can also be solved using DP, which is something like at this position, am I able to reach that position or not with the number of tips I have. So maybe solutions have something. Yeah, this is more of a greedy problem, but this is also people consider this as a DP. Going ahead, jump into similar thing, but I guess each element represents the maximum of a forward jump of from index I. In other words, you can okay. And return the minimum number of jumps to reach -1. So basically, it's the number of jumps now. And it was number of. So it's the same thing, but I whenever I'm making a transition, that means I'm going to jump till there and pick that number up. Right? It's basically direct solving. So for each of the numbers, I'm going to take okay, so I've used DP to solve this problem. So basically, here they're asking the minimum number of steps that you can use to reach the last one. It's basically the number of jumps. So I can think of so like if I begin from ith position and I have nums of I possibilities to take jumps, but which one should I take will depend on basically I can only take one, like considering that. So if I take one and if I jump to some position, which one will take me to the end with minimum steps, right? So that's what I've written here. 1 plus basically I've taken for each of the um, positions from end to beginning, and for those position, at ith position, I'm taking from basically, I'm taking all the possible jumps. So for each jumps, I'm calculating the current DPS, either whatever the minimum I have. I'll take one step and that particular jth point, how many steps I have at that point, and then I'll store it. The next possible step, I'll calculate that position and also check whatever position or whatever I already calculated, and taking the minimum of those two to calculate the DP at each point. And that's how I'm using the DP here. And it got submitted properly. But I think people are using instead of DP, they're I think using something else. They're not using DP, but some R test, and the min steps is equals to no min steps. This is DP. Yeah, this is DP. Some are taking DP and some are using something else, but DP solution works. That should be okay.